All right, guys, we're back with section 4, solving quadratic equations by completing the square. So previously, we solved quadratic equations by using the square root property, and now we're going to complete the square to write perfect square trinomials, and then solve quadratic equations by completing the square. So some new vocab of definitely completing the square. So you have previously solved equations by taking the square root of each side. Now this method worked only because the expression on the left-hand side was a perfect square. In perfect square trinomials, in which the leading coefficient is 1, there is a relationship between the coefficient of the x term and the constant term. So if you have a perfect square trinomial, x plus 5 quantity squared, and you FOIL it out, you would get x squared plus 2 times 5x plus 5 squared, or x squared plus 10x plus 25. Now, this always happens with perfect square trinomials, that if you take half the middle term, so half, or the coefficient of the middle term rather, and square it, you'll get the constant term. So for example, if I take half of 10 and square it, I get 25. So to get the constant term, divide the coefficient of the x term by 2 and square that. Any quadratic expression in the form x squared plus bx can be made into a perfect square using the method called completing the square. So to complete the square for any quadratic expression of the form x squared plus bx, follow these steps. Take half of the coefficient of the x term, or half of b, square it, and add it to the result. Okay? All right, so find the value of c that makes x squared plus 4x plus c a perfect square trinomial. So this is like x squared plus bx, and the value of b is 4. So if I use algebra tiles, this says that x squared plus 4x, if I arrange it so that the two sides of the figure are congruent, in other words, I have an x squared here and a 2x over here, and 2x is over here, then I can fill this in with units, and you would just have 4 little units here, so you'd have to add 4. Or you can use the complete the square algorithm. So I take half of b, or half of the coefficient of the x term, so half of 4, which is 2, square that result, which is 4, and so I would add that to make it a perfect square trinomial, so add 4. So therefore, the value of c is 4. Also notice that x squared plus 4x plus 4 can be factored as x plus 2 quantity squared, since now it's a perfect square trinomial. Okay, remember with perfect square trinomials, you can write it as something squared plus 2 times the something plus the last thing squared. So the first thing squared is x squared, so that you could write that as x squared. The last thing squared is 4, so I could write that as 2 squared. And as long as the middle term is twice each of those things, so twice 2 times x, I know it's a perfect square trinomial. And it is, because 2 times 2 is 4, so that make the middle term 4x. And it works out right. So I can write it as x plus 2 quantity squared. Now, how I know this is a plus instead of a minus is this term right here has to be plus instead of a minus. Okay? Here's a couple for you to try. I'm going to do 1 and 2 just as extra ones, and then leave 3 and 4 for you to try on your own, and then I'll go over those. So for number 1, I'd take half of the coefficient of the x terms, so negative 18 divided by 2 squared. So that would be 9 squared, which is 81. So it would be x squared minus 18x plus 81. So the value of c is 81. Well, that's all they asked for. So if I factored it, it would factor into x minus 9 quantity squared. Okay. Number 2, x squared plus 22x plus c. If I take half of the middle term and square it, that's going to give you 11 squared, which is 121. So that would mean that c equals 121, and the trinomial would be x squared plus 22x plus 121. If you factor it, it would be x plus 11 quantity squared. Okay, go ahead and try those other 2 and pause the video. Hit play when you're ready. Okay, we're back. So for number 3, you should have got C is equal to, well, let's see, the middle term is 9x. If I take half of that, be 9 halves squared. Now 9, you can't evenly divide it by 2, so just leave it a fraction, and it would be 81 over 4. So C equals 81 over 4. They're not always going to be integers, and that's okay. We'll deal with fractions. If you factored it, okay, it would be x plus 9 halves quantity squared. Okay. Now, here's a little trick for whenever you want to write it in its factored form. It's always going to be x plus whatever you squared to get the value of C. Okay, so I take, or half the middle of term. It's half of the middle term. Okay, so it's going to be x plus half of 9, or 9 halves. Okay, just leave it as a fraction. So number 7, or number 4 rather, you do half of negative 7 squared, which would give you 49 over 4. Now again, 49 fourths does not even, 4 doesn't evenly divide into 49, so just leave it like that. Don't change it into a mixed number of 42 and a fourth. Just leave it the fraction like that. So that would be the value of C, and your trinomial would be x squared minus 7x plus 49 over fourths. Again, if you do x plus or minus, in this case minus, half of the middle term, quantity squared, that gives you the factored form of that perfect square trinomial. Okie doke? All right. Well, that's it for this video. We'll finish this section with the next one, and we'll see you there. Take care.